23 to 28.
Listen to part of a lecture in a history class. You all probably know that Johannes Gutenberg contributed much to the technology of printing, including the invention of the mechanical printing press. And he developed an oil-based ink just for his printing press. Water-based ink has the advantage of drying quickly, but oil ink is stickier, so it attaches to the metal blocks more effectively. What I want to focus on today, though, are the inventions that came before Gutenberg's printing press, that were stepping stones to it. So, can anyone think of an invention that helped make the printing press possible?
Well, this may sound silly, but the letters in printed books are small, and my grandma couldn't read until we got her a pair of reading glasses. Perhaps the invention of eyeglasses was a stepping stone?
Yes, it's true that books became more popular after eyeglasses were invented and made it possible for many people to see small print. But there's a major invention that preceded the printing press, and Gutenberg is widely considered to be its inventor: metal movable type. It's a system of printing that uses detachable pieces, each of which represents a letter, punctuation mark, or character. It was unquestionably an improvement on the woodblock method already in use in Europe. That method of printing used a block of wood. The wood was cut away, and what was left behind formed the characters or image to be printed. It was first developed in Asia, but Europeans used the woodblock method to print images on cloth. Anyhow, so movable type is certainly more durable than woodblock. But did Gutenberg really invent movable type?
I'm going to say yes. I mean, before him, they had scribes who copied documents by hand, right?
You know what? The Chinese would be surprised to hear your response. They were using a system of movable characters about 400 years before Gutenberg developed his own version in AD 1450. Let me point out that, although the Chinese invented movable type, woodblock printing was certainly better suited for Chinese writing system, which consists of more than 40,000 characters. A woodblock could be used again and again to reproduce a page of text or an entire scroll. But if you used movable type, just think of how time-consuming it'd be to rearrange tens of thousands of mobile metal characters in order to print something. What a tedious task that would have been. The Chinese inventor Bi Sheng created the first movable type system in AD 1040. His type was made of baked clay. He took an iron plate and set his clay types close together, and when the frame was full, he had one solid block of type. He heated up the plate to make it warm. The warmed-up plate softened the clay. Then Bi Sheng took a smooth board and pressed it onto the clay types so that they would all be of the same height. He then inked his clay types and pressed them on paper. When he wasn't using them, he wrapped them in paper and stored them carefully. If they needed to be used again, they had to be reset on the iron plate and reheated. Now, Bi Sheng's clay types were fragile, so it wasn't practical to apply them to large-scale printing jobs. Actually, metal movable type was first created in Korea in the 13th century, but in fairness to Gutenberg, he invented the molds that allowed for mass production of individual pieces of metal type, with each character on a separate block. Before this, each piece of metal type had to be individually carved by hand. Now get ready to answer the questions. You may use your notes to help you answer. 23. What is the main topic of the lecture? 24. According to the lecture, in what way were eyeglasses helpful in spurring the invention of the printing press?
"25. What does the professor say about Gutenberg's metal movable type?"
"26. According to the professor, why was woodblock printing superior to movable type for Chinese texts? "27. According to the professor, what are two characteristics of Bisheng's invention?
"28. According to the professor, what is the significance of Gutenberg's molds?"
(29 to 34). Listen to part of a lecture on earth science. Let's continue our discussion on water hydrology. Just to bring to mind what we discussed the last time, hydrology studies the properties, distribution, and effects of water on the surface of the earth, beneath the surface, and in the atmosphere. But this time I'll focus on a specific application of hydrology called snowmelt. Now, some of you might not be aware of there being measurable water coming from snow. So let me just briefly explain what snowmelt is. It's the water that's created when the temperature is high enough to melt the snow. Pretty straightforward, huh? Snow melts, and when it does, it turns into water. But snowmelt is special in a sense. The science of hydrology makes a distinction between snow and other forms of precipitation, such as rain, because there's a significant time lag between the time the snow falls and when it's converted into water runoff. Why should people be so concerned about snowmelt? Well, it's an important source of water in many parts of the world. In some areas, it constitutes up to 90% of the annual water supply. You see, runoff from snowmelt recharges groundwater supplies and replenishes surface water caches, such as rivers and lakes. So, having an accurate measurement makes good water management possible and gives us some idea whether the needs of nature, residents, farmers, and businesses will be met. so I guess I don't have to tell you how important hydrology is. Let's look at the ordinary farmer. You know, changes in the amount of snowmelt from year to year can cause a lot of difficulty, in some cases even disaster. Too much runoff can lead to flooding, right? But too little could lead to drought. What if there was a projected shortfall in snowmelt runoff? Here is where such projections are useful, because farmers can make adjustments to make up for water shortage. They can modify the amount of land to cultivate, or choose a different type of crop to plant. They could also apply conservation measures so that the existing water supplies can last through the growing season. And this is where it all makes sense. If the forecast turns out to be true, then the planning will have helped the farmer avoid horrendously large financial losses due to crop failure. Now we know why we have to measure runoff and make these projections. Well, just how are these projections made? The extent of snow cover is one factor. At first, it seemed to scientists that this would be easy to measure, but they realized that not all places are the same. But by adding variables like elevation, wind speed, air temperature, the moisture content of the snow, and the rate at which the snow melts, they were able to get a more accurate measure. Hold on. You might have seen different kinds of snow. There's some that's powdery, some that's icy. Powdery snow contains less moisture and usually produces 60% less snowmelt than heavy wet snow. And the temperature of the air is important because if the snow cover partially melts and then refreezes, you'll have this hard crust, and this will affect how quickly the snow will melt at a later period. It's even worse if the weather stays cold. It means there'll be very little early spring snowmelt. Okay, going back to those factors, the characteristics of the soil can also affect just how quickly snowmelt can reach a stream or river. If the soil is frozen or is mostly clay, it'll absorb less water. In this case, the snowmelt would be unable to seep into the ground and make its way to groundwater storage. What will happen? Well, it'll simply become runoff, and this may increase the possibility of flooding. Now get ready to answer the questions. You may use your notes to help you answer. 29. What does the professor mainly discuss?
.30. According to the professor, what difference is there between snow and other types of precipitation?
.31. Why is snowmelt of concern to residents where it occurs? .32. According to the lecture, what are some factors that affect the amount of snowmelt? 33. According to the professor, what is the significance of a long winter? (34) According to the lecture, what are two factors that can cause flooding in areas with snowmelt?